Hello, welcome. This is LeetCode questions. I'm going to be doing number 515, find the largest value in each tree row. This is a medium question on LeetCode, and I know that recently Facebook has been asking it, so I just wanted to cover it. So let's go ahead and look at the question, right? You need to find the largest value in each row of the binary tree. So that means, on each level, we want to know, for example, on level 0, which is a value of 1, as we can see here, that's the only value, so that's going to be the largest value. But once we start going down and the tree gets larger, we want to be able to differentiate between, first of all, which row we're on, but also we want to keep track of just the largest value as we traverse. And as you'll see soon, it really doesn't matter what method we use to traverse this tree. In this particular example, I'm going to be doing depth first search. But as long as we keep track of the level that we're on each recursive call, it really doesn't matter which method we use, because at the end of the day, we'll just be looking at what level are we on, what's the current value that we have for that level, and is the node that we're on the larger of the two. So the answer format for this question is going to be a list of integers. And so that kind of gives you an idea of the data structure that we can use to sort of find out whether or not the current level that we're on has a value. And it also provides us with a good way to use the level as an index to get the current value and compare it. And you'll see what I mean in a second. So as I mentioned, we're going to be traversing the tree, keeping track of the row, and we're going to be using a recursive function with an argument called row. It's going to be an integer, and it's going to default to 0. So as we start at the root, row is going to be equal to 0. But as we recursively call to the left subtree and the right subtree, we'll just be incrementing row by 1. Then we'll be comparing the node's value with any other nodes that appear at the same level and updating them one by one. So, for example, we'll go down the left side. We're going to have 3, and then we're going to recurse down the rest of the tree. But as we go to the right side, we already know that we have 3 at level 1. Compare it with a 2, and we're going to know that 3 is the larger of the 2. And that logic applies to any subtree as far down as you can go, because we'll be keeping track of the row per recursive call. So the way that we know whether or not we're hitting a new value or one that already exists is whether or not the list size is equal to the level. So originally, we're going to be having an empty list. And so we're going to be saying, okay, at level 0, the list is empty. 1 will be the value for that. That'll be this first if statement. And then otherwise, if there's already a value, we can just find the max between the two. So let's start at the root node, right? We hit 1, and we see that the list size is equal to 0. So we're going to go ahead and add the node value to the answer list. So now what we can do is we can traverse down, and we're going to hit 3. Now, at 3, the list size is still 1, because we've only added one value, and the level is 1, because we start at 0 and we go down to 1. So now the list size is equal to the level. So we know that, basically saying that the list size is equal to the level is just a fancy way of saying, is this the first time we encounter a value at this level? So in the case of 3, yeah, it's the first time. So we're going to go ahead and add 3 to our list. The list size gets larger, and we're going to traverse down to 5. As you can see, we're now at level 2. Start at 0, go to 1, now 2. And the list size is equal to 2. So we know that we can add this value to our list. Now the next recursive call is going to hit a null node for both sides. So we're going to bubble up and eventually go down the right subtree. So now at the right subtree, we see that we are at a level 2, but the list size is now 3, which means we need to do a comparison and say, is the current value that we have for the second level, which is currently 5, is the node that we're on larger than that? So as you can see, 3 is not larger than 5, so the index for that level will remain 5. Or sorry, so the value for that level will remain 5. Now we're going to be recursively bubbling back up. We go all the way back up, and then we'll go down the right subtree. So now we have 2. So we say, the list size is definitely not 1. So what we want to do is we want to see what value do we have for the index of 1, and is the node that we're on larger than that value? Well, in this case, we're going to be comparing 3 with 2. 3 is the number that we currently have. 2 is the number that we have in our node. And we see that 3 is larger. So now we're going to bubble down, we're going to recurse down to 9. And we're going to say, okay, is the current value that we have for level 2, which is index 2 over here, 0, 1, 2, is the value that we have, which is 5, is it going to be larger than 9? So we're going to do a comparison. And as you can see, 9 is larger, so we're going to update our value to 9. And as you can see, using this methodology and this logic, the answer that we get now matches the answer that is provided by LeetCode. So with that, I'm going to go ahead and jump into the actual implementation of this code, and you'll see that it's not quite difficult. So here we are in the code implementation. We know that we need to return a list of integers at the end of the day, right? So what I'm going to do is I'm going to go ahead and just create a variable right here. And I'm going to go ahead and just call it largest values. And that's going to be equal to an array list. Now, we know that we need to recurse down the tree. So I think that the best bet would be to create a second function down here. And it's going to be a void return type. And that's because since we have a list, we can just go ahead and change these values, update these values while we recurse down the tree. And then at the end of the day, we'll be returning the actual list. So we don't exactly need to be returning anything in this function. All we're going to be doing is just updating our array list. So I'm going to go ahead and call this just depth first search, because we're doing depth first by recursively going down the entire tree and then visiting the sub trees. And eventually, we're not going to be doing breadth first search. So what is the first argument? The first argument is going to be the actual node that we're on. So I'm going to put tree node, and then I'll just call it node. The second value is going to be our list of integers, and I'll just call that largest values as well. And that should be enough for us to start writing this actual recursive function. So as with any recursive function, the first thing we want to do is identify the base case, which in this case will be if node is equal to null. That means that we have recursed down an entire subtree and there are no more leaves. So we can say if we hit an empty node, we're done with that branch, and we can just return out of the recursive function, basically breaking out of it. Otherwise, what we need to do is we need to say if largest values, our array list, if the size is equal to the level. There we go. I hope one of you guys caught that. I forgot to add our level argument. This will keep track of which level we're on. So, yeah. Anyway, so if our array list largest values.size is equal to the level, so we'll start off at level 0, we're going to have an empty array list. So our empty array list size is 0, level is 0. So we're going to be adding 1 to our array list. So basically we're saying if largest values.size is equal to the level that we're on, all we need to do is just add our value to it. So we can say largest values.add and then level. Oh, sorry, node.val. Okay. Otherwise, what do we need to do? Well, if we've made it this far, what we need to do is compare the value that we have already set in our largest values array. So for example, let's say we already have 5 at our index of 2. Whenever we recursively go down to 3, we're going to need to compare 5 and 3 and say which one is largest. So what I can do is I can say largest values dot put for the level that we're on, give me the max of the current value at that level. So it'll be largest values dot get level and the current node, so node.val. And that should be it. So what I can do is I can go ahead and run this function, and let's see if that works. And as with any first dry run, there will always be an error. But what this is it's not put, it is set. Oh, Jesus. What did I do? Ah, of course. I haven't recursed down our tree. We're basically not doing anything after we set the value. So what we need to do is recursively say, all right, we've processed the current node. Let's go down the left side, and we'll pass the level +1, and then we'll pass our array list. And again for the right side. And let's see what happens. Up here again, I need to call the function. So dfs root 0, because we start off at level 0, and then we will pass our largest values array list. So there we go. And as you can see, we got the right answer. Let me go ahead and submit it, see if that works. And there you go. I hope this was helpful. As you can see, sometimes I don't know, things just slip out of my mind, but overall, I hope it didn't really confuse you too much. But if you liked the video, then, I hope it helps. Good luck in your interviews. I know that the interviews are stressful, but with enough practice, you should be fine. So, have a good rest of your day, and I will see you guys in the next video.